When you think about it, machine learning, or ML, is pretty much everywhere. It's the magic behind that app that can translate a menu for you on the fly, and it's the brain inside those self-driving cars we're starting to see. It's really the engine powering so much of the incredible tech we use every single day.
I mean, have you ever stopped to wonder how your phone knows the fastest route, down to the minute, or how your music app just gets you? It serves up that perfect next song you've never heard before, but you immediately love it. How does that happen? Well, the answer to all of this, you guessed it, is machine learning.
All right, let's break this down with a simple example, predicting rain. Now, the old school way to do this, you'd need to build this giant, ridiculously complicated physics simulation of the entire atmosphere. We're talking fluid dynamics, super heavy stuff. But the machine learning approach, it's completely different. Instead of programming all the rules of physics, you just feed the system a ton of past weather data, like decades of it, and you just let it learn the patterns on its own. It figures out the connections that lead to rain. See? It's a huge shift from being told what to do to learning from experience.
And at the very heart of all this is something called a model. It's basically a piece of software, but you could just think of it as the brain of the whole operation. This is the thing we actually train with all that data, and its job is to make useful predictions or even generate new stuff for us.
Okay, so how do these things actually learn? Well, there are a few different methods, but let's kick things off with the most common and probably the easiest one to wrap your head around, supervised learning.
The absolute best way to think about supervised learning is like this. Imagine you're a student cramming for a huge exam, but you've got a secret weapon, a stack of old tests, and they all have the answer key. So you go through them, question, answer, and pretty soon you start seeing the patterns. You learn what the right answers look like. Well, an ML model does pretty much the exact same thing, just with data that we've already labeled with the correct answers.
So one of the main things a supervised model can do is something called regression. And really, all that means is it's trying to predict a number. That's it, a specific numeric value, like a price or a time or a temperature. So, for instance, if you want to predict a house price, the model will look at things like the square footage, the neighborhood, how many bedrooms it has, all that stuff. Or think about your ride-sharing app. To guess your arrival time, it's looking at current traffic, the distance, maybe even the weather. In both cases, it's just crunching all those different pieces of information to spit out one single specific number. Okay, but what if you're not trying to predict a number? What if you're trying to sort things? Well, that's where the other big type of supervised learning comes in. It's called classification, and its whole job is to put things into categories, to sort them into the right buckets.
And this really breaks down into two main types. First, you've got binary classification. Think of it as a simple yes or no decision. The classic example is your email inbox. Is this message spam or not spam? Then you have multi-class classification. That's when the model has to pick from more than two choices. Like, is the weather today going to be rain, hail, or snow?
Right. But what happens when we don't have the answer key? What if the model has to figure things out all on its own? Well, that's where things get really interesting. And this is what we call unsupervised learning.
So with unsupervised learning, we basically just dump a massive pile of data in front of the model. With zero labels, zero correct answers. We don't give it any hints. Its entire job is to just stare at all that messy data and find patterns, to find structure all by itself. And this is super powerful, because it can uncover connections that a human being might never, ever notice.
Yeah, a really common technique here is called clustering. The model just takes all the raw data and starts finding natural groups, or clusters. For example, if you give it tons of weather data from all year round, it might notice 4 distinct clusters of data points. Now, the model won't know to call them spring, summer, fall, and winter, right? But a person can look at what the model found and go, oh, it found the seasons. This is exactly how companies discover completely new groups of customers they had no idea even existed.
All right, let's get to the really fun, cutting-edge stuff. We're going to look at 2 more advanced areas that are totally pushing the limits of what's possible right now: reinforcement learning and, of course, generative AI.
So first, reinforcement learning. The easiest way to picture this is to imagine you're teaching a robot how to walk. Every time it takes a good step without falling, you give it a point, a reward. Every time it stumbles, you take a point away, a penalty. And over millions and millions of attempts, it just learns through trial and error what the absolute best strategy for walking is. That's pretty much reinforcement learning in a nutshell.
And that, of course, brings us to the one that everybody is talking about these days, generative AI. These are the models that go way beyond just predicting or sorting stuff. No, these models create. They actually generate brand new, totally original content. Images, text, you name it. All from a simple instruction you give it.
And the range of what they can do is just mind-blowing. You can have a model turn your text prompt into a whole essay, or a beautiful piece of art, a short video clip, or even lines of computer code that actually work.
So let's talk about some real examples. You could go to a model like Bard and ask it a super complex question, and it'll write back a really detailed answer. Or you could go to an image model like Imagine and give it a totally crazy prompt, something like a photo of an alien octopus floating through a portal while reading a newspaper, and it will create that exact image for you from scratch.
And there's a really great way to understand how this actually works. Think of these models as master mimics. They're kind of like a comedian who learns how to be funny by studying thousands of jokes. Or they're like an artist who learns a specific style by looking at countless paintings. Or even like a cover band that learns to sound exactly like the original group. They just soak up all the patterns so deeply that they can start creating brand new things that still feel authentic to that style.
Okay, so we've talked about supervised, unsupervised, reinforcement, and generative learning. That's a lot. So let's kind of zoom out for a second and talk about why any of this actually matters.
You see, the really important thing to remember is that these different kinds of machine learning aren't separate things. They all work together. From predicting the traffic on your morning commute, to finding new ways to group customers, to generating incredible new art, they're all combining to literally reshape our world and unlock possibilities we couldn't even dream of a few years ago.
And that kind of leaves us with one last big, fascinating question. We've managed to teach machines how to learn, how to predict, and now how to create. We've built these incredible tools, so what should we ask them to do next?